Hi, everyone. Thank you for joining us for our next live stream. I'll be your producer for this session. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Thank you for joining.
Hi all, thanks for joining. We've got our Bring AI to SQL with Embeddings, Search and RAG. I'm Greg Lowe. I know there are many places you could be at the moment instead of attending here, but we're really glad you've come to join us here. I'm Greg. I'm a long-term data platform MVP and part of the Microsoft Regional Reactor program. I've put my contact details there, so please don't be a stranger, stay in touch. And my friend Anu is here as well.
Yeah, thanks, Greg, and nice to see you. So hopefully, it's nice and sunny in Melbourne.
Ha.
And and so, hi everyone. I'm Anupama Natarajan. You can call me as Anu, and I'm a data platform MVP as well as an AI MVP, and also a Microsoft certified trainer. So really excited to present this session along with Greg. And yeah, so we both are in the winter side today. So it's about to rain here. So that's the weather here, Greg. Cool. So thanks everyone for joining our session today. So the first and foremost, this particular session is part of the 60 days of data and AI, and this is proudly powered by the Fabric community. So there are a few, you have been watching us over the last 60 days. There is a lot of sessions that has been happening, focusing on certifications, focusing on how do you build your community, and also learning to know more about Fabric and Power BI related topics. So all these sessions will also help you to guide towards getting certified. So mark this URL, https://aka.ms dd/cert, and this URL is really important. So if you want to grab some free vouchers and stuff, you should be able to go and apply there. And yeah, just get certified. So whether it's DP-600, 700, or 800, you have opportunities to get certified. And also, for certification preparation, apart from watching these sessions, you also can join a study group. So there is a lot of study groups that are happening, whether in major cities and across the world, whether it's in person or virtual, you can pick your choice. And if you want to see the list of study groups that are available, you can navigate to this URL, aka.ms/dd/study group, and you'll find all the details, and you can pick the one that is local to you if you want to attend in person or virtual. And also, in addition to that, you can see the different user panels. I really love these user panels because this is an opportunity for you to actually share your thoughts about the product to the product team. So we have for Fabric, we have the Fabric user panel for Fabric IQ. Similarly, you have the user panel for that and also for SQL. So make use of this opportunity so that your voice can be heard by the product team.
Yes, I'd really encourage you to get involved with the user panels. I've signed up for all of those, and I must admit I really enjoy the chance to get to look at what the developers of the product are thinking about. And there's a good opportunity to have good influence on what ends up coming out the other end. And so strongly encourage you to do that. Hey, so listen, this session is one of many that are being produced. And what we've got, there are 2 time zones. So there's an EMEA and an APAC. So if you can't make one, maybe you can make the other. For these, there's a series of DP-800 sessions. But in addition to that, there's a whole lot of, I would put it in the really interesting camp, the things like I'm just getting started, getting from that to I made this, and suggestions on how to get certified and things like that. There's a really interesting set of additional sessions that are part of this series. Now, we've also got a bunch of moderators available today to help you. So if you have questions as we go along, please, this is interactive, so please put them in the chat as we go. And we've got a number there. So Alpa, one of our data platform MVPs and a trainer. We've got Kevin Arnold. I saw talking in the chat a little while ago. So hi, Kevin's there as well. And I saw Marty was there as well. So look, and I note a number of other people I've already recognized in the chat who are very knowledgeable people who are able to try and help you. So I think if you put questions in there, you'll be surprised how quickly you'll get a really high quality response. And if there are things that are of interest to the whole group, then we'll also get those pushed back to us, and hopefully we can get to look at those inside the session as well. So look, what we're covering off today is just part of the detail you need for DP-800. Obviously, it's a substantial exam and certification associated with it. And this one here, we're looking at what's involved in designing and implementing the models. So embeddings models in general for working with text within SQL, doing intelligent search and RAG queries. So these are retrieval augmented queries as part of SQL. Now, this is, as I said, part of the DP-800 exam, and which is all you need to get to the SQL+AI Developer Associate. The main thing here, this is a thing I've had for many years. I've had people asking what's happening with the normal SQL style certifications. This is the closest thing we have to a current SQL certification. But importantly, it's not just SQL Server details. It's also a whole bunch of AI details as well. So it's not just that one thing. So I have had friends who've said, look, I think you could possibly pass the exam without worrying about the AI parts of it, but don't do that, right? So you'll find that you really do need to know about it because it's a substantial part of the exam. Look, the other reason this is really important is that what I'm finding is there's an interesting sort of CEO-driven technology thing happening at the moment. Used to be always that technology things would bubble up from the technical people in the company. But what I'm striking more and more is technical people who are telling me their CEO has gone off to some conference and come back with a whole lot of questions around how AI might apply to the database. And it's really important that you're in a position to answer those questions or to play a meaningful role in discussions where this is being, where things are being kicked around. Because I've heard other people like DBAs and developer friends who say, oh, look, this will never happen in our organization for quite some period of time. But even if it's not happening immediately or in production environments and things like that, you need to be in a position where you can contribute so that you don't get sidelined when the discussions happen. Now, the foundational structure of this exam, it's really three pieces that are about a third each. The first is very traditional design and develop database solutions. So this is all your standard, how do I build tables and design indexes? How do I do programmability? Like what do I need to know about procedures and functions and triggers and so on, but also a bunch of advanced T-SQL patterns as well. The final note that they've made in that one too, again, don't underestimate, but this is AI-assisted authoring tools. I would strongly encourage, if you're doing this exam, make sure you're always working with very up-to-date versions of SQL Server Management Studio. I noticed version 22.8.2 came out yesterday, but just keep an eye on those. But most of these tools now have a degree of AI integration inside them. I noticed the first time I was working with Management Studio and it started prompting me with what it thought I was about to write. That was a really interesting experience for me in SQL. I mean, I was used to it in Visual Studio for other languages, but not in SQL. The second pillar of this is data security and compliance. And so I would think the core areas there of security and compliance and all, that's fine. That's very standard SQL Server type content. The one that I think will be a little bit of a challenge to a lot of people if they haven't done enough work with it is the continuous integration, continuous deployment using SQL projects. And so make sure you're across that and make sure you're across Azure integration and deployment as well. And then, of course, there's the AI capabilities. So this is the intelligent search, embeddings, vector data, the issues around vector indexes and so on, and building out retrieval augmented queries. There's a lot to be covered in this exam. But first up, we need to look at the models and embeddings, and Anna is going to tell us about that.
Great. Thanks, Greg. And so as we were seeing, right, so integrating AI capabilities, and now we have these capabilities available in SQL itself. To start with, we are going to look at what it takes in terms of designing and implementing models and embeddings with SQL. So first and foremost, the important part I would be saying, or important T-SQL command that you will be looking at is the create external model. And definitely, like, there is going to be questions in the exam related to that. So the purpose of this particular T-SQL command is to integrate AI capabilities within your database. So for instance, like you can actually, if you notice the syntax of this particular T-SQL command, you can see the location parameter, the credential, the model type. Location is nothing but this is basically telling where is your model available. So your Azure OpenAI endpoint URL that you are using, saying this is where this is the model, that endpoint where I have hosting my model. Credential is similar to your database scoped credential. So preferably for security purposes, we recommend that you use managed identity. And so that is again an important thing to consider because security is paramount. And it is always recommended that you go with a system assigned managed identity because it provides passwordless access for you. And the third parameter, if you notice in there, it is the model type. So you can either use embeddings, especially if you are generating vectors. So vectors are nothing but converting your text representation into numbers. And that's what we talk about. Or your model type can be completions. Completions is nothing but dealing with text. So it is really important that when you are preparing for the exam, like understand what each and every parameter within this T-SQL command comprises of, and what are the best practices associated with that, like the one I mentioned about security and the model types that are available, as well as like how can you pick the right model? Because that is again an important aspect. Because when you're choosing the model, not only you look for capabilities, but also like, okay, what is the cost? What is the token limits that I have got? And as well as like, what is the latency that I have to consider? So these are important aspects, especially when you are trying to bring in and integrate AI models with SQL. Great. But the next question is, should I embed everything? So there are columns that are needed embedding, and there are columns that doesn't need embeddings. So what is embedding is nothing but typically when you are doing, we used to store everything in plain text, right? So even in SQL, if you look at it, like all our data types where it is like a product description or a customer review text or any technical documentation, we store it in plain text. And when we are looking for that information, we actually do a text search. But now with the AI capabilities, the semantic search are getting more and more popular. To do semantic search, which is nothing but like if I'm looking for a text called annual report, right? So normally in a text-based search, it is going to go and search for the word annual or report or the combination of the word annual report. But what it doesn't bring is the contextual. The report, the name, the word report can be called as like in a few other things, like for instance, articles or some other synonyms that you can use for the word report. But in a pure text-based search, it won't be picked up. But in you're using semantic search, it will automatically pick up because it was going to look at the related synonyms and it is going to bring that in your search results. That is the advantage of having semantic. So semantic is all about related information also you will be getting as part of the search results. But how do I achieve that? And this is where embeddings come into the picture. So whenever you're storing the data in SQL Server, so especially like things like product description, as you saw, or customer review text, you can actually convert the text into numbers. So basically you keep the text version and also like you create the vector representation of that particular text. And what it allows you to do is to for SQL to perform semantic search efficiently. But the question comes in like, do I need to just vectorize every single column that I have got in the database? That is not the case. So just pick and choose the right columns where you want to do the vectorization. The next part is chunking strategies. And you will all get to know like, why am I talking about this down the lane when we talk about RAG patterns? We looked at first thing is we have to vectorize the data. And then the next part is like, okay, so when you have large piece of document or text, sometimes it is going to be hard to vectorize in one go. So this is where the chunking strategies come into the picture. So you have in SQL Server 2025, the AI underscore generate underscore chunks function. So where you can just apply the different chunking techniques in there. So these are the different types of chunking strategies that are available. You can chunk it based on fixed size. We can say like, okay, after n number of characters, I want to do the chunk. Or you can go for sentence based, where you can say split based on sentence boundaries. And the main advantage of that is you can preserve the meaning, but you will get different sizes of chunks because some sentences may be large, some sentences may be small. Then you have paragraph based chunks or semantic based chunks. Sometimes you have to, when you're chunking it, you don't want to lose the meaning, right, of the chunk. So sometimes you will just split it based on some semantical or like ideas or topics related stuff. The last one is overlapping. Sometimes you need to have some sort of contextual information between what was the last chunk to this chunk. So chunking is nothing but just breaking that text so into sizable so that we can vectorize them. But these are the different strategies that are available that we can use. Cool. So we talked about the embeddings, we talked about chunking. But first thing is what happens? Like I have a database and what is the process that I have to follow in terms of creating those embeddings? So we'll start with your source data. So this is where you have got your product reviews or product description. Wherever possible, we need to chunk. We will do the chunking using taking any of our chunking strategies. And then we use the AI generate embeddings. That is the function, the T-SQL function we will use in order to generate the embeddings that we require. So this is where we are converting the text into vectors, right? And then we want to store that output, which is basically a vector representation in SQL Server. So what is how we can store it? Do we store it in which data type? And that's where you have got the vector data type that is now available, where we can store the output of your embeddings into that particular data type. And then finally, like you can index the vectorized column, which has got all the data represented in numbers. And that is what is going to be used when you are going to do the search. So from an exam point of view, make a note of all these key T-SQL functions. The AI generate embeddings. The purpose of that is to convert text to vectors, the vector data type, vector distance T-SQL function. Suppose if you have to calculate the distance between two vectors, and why that is important. Suppose if you have to find out how you have two set of pieces of text, how related are they? If you calculate the vector distance, if the vector distance is closer for these two, then they are related. If they are far apart, they are not related. And that's where the vector distance T-SQL function will be handy. And finally, the AI generate chunks. If you want to split the long text, which is your source text, into chunks, this is the T-SQL function you'll be using for that. So make sure to go through each of these T-SQL functions before your exam. So once you have created your embeddings, it doesn't stop. It's not like one time we embed. So product description can change, or sometimes someone has provided a review. It was not correctly saved and it needs to be updated. So this is where the embeddings maintenance patterns come into the picture. So how do I update the embeddings once I have created it? It can be trigger based, and each one of these I'm explaining, right, has got pros and cons. So you have to pretty much use the scenario, what is going to be applicable for you. So trigger-based is like you can generate embeddings automatically whenever the data. So for instance, if the text is getting updated, automatically you can update the embeddings also. But as you can see here, like depending on the volume of updates that are happening, right? So always keep in consideration of that. Batch refresh, pretty good because it is low write overhead. You are doing only batch calls, but there is going to be differences like until the refresh happens, your data is going to be in stale, right? Change tracking is another efficient one. So where you identify exactly what got changed, and then you just update only those rows. So in that way, like it is much more efficient because you're touching only the updated rows. And lazy or on demand, this is again regenerating your embeddings, but it will be running it as a background process. So not like a trigger based, and it is not going to impact any of your things. So make sure like you pick and choose the right maintenance pattern. So if I have to totally summarize in terms of what are the key takeaways that you have to take from an exam perspective, understand what is this T-SQL function is like the create external model is, what are the parameters that I pass, what is the best practices in terms of that I have to follow when I give those parameters. Identify what are all the columns that needs to be embedded, because the data types that needs to be embedded. Don't create embeddings for IDs, numbers, or status codes, because these can be, you can just do a where, and you can do a select statement itself. You can go and write conditions to check them. Whereas like with descriptions and when you have large text, and that's where embeddings play an important role. Remember all the different chunking strategies that I talked about, like the smaller the chunks will give you better precision, and larger the chunks, it is going to maintain the context. So that is where you have to make the decision in terms of what is the best chunking strategy to choose for your scenario. And remember those functions that I mentioned, generating embeddings, the vector data type, and then how do you create your chunks. So make sure to go through each of these functions that are available. And also don't forget the maintenance patterns, because vector data once created, it also needs to be maintained on an ongoing basis. So look at all the different maintenance patterns, understand it, so that from an exam perspective, you know which maintenance pattern you use for which scenario.
Thanks, Anu. That's awesome. Actually, one thing I will throw in there too, it seems really obvious that maybe you should do things trigger-based, where as the data changes, you think, oh, I'll run off and update the embeddings and pop that in. But keep in mind that that's taking a sort of a dependency on an external thing. And you've got to ask yourself, do I really want that happening in the middle of my trigger, right? And you also need to think, well, what happens if I change the data and the trigger fires, and then the call to update the embeddings fails? Does my update then fail? And so on. So you need to think through what's actually happening with the different stages of that. And one thing we often use for this sort of thing is SQL Service Broker, actually, because it's the only way at the moment we can build the equivalent of an asynchronous trigger. Now, we've often used this in the past for geolocating data. So I put an address in for a customer, a trigger fires, that puts an entry in a service broker queue, and then in the background, the service broker runs off, executes the code to do the geolocation, and then updates the data. But that happens asynchronously. And importantly, you may need to look at the same sort of pattern when you're working with embeddings instead. I'm hoping that this will become a little more formal somewhere in the product along the way. It's interesting if you've looked at the new Azure Horizon DB as an example. They have a concept of durable pipelines where when you make changes, you can put an entry in a pipeline and that ends up going off and executing things asynchronously. So I think I'm hoping we'll get more asynchronous ways of doing this sort of work. But it's so important you don't end up building dependencies on external things in the middle of your triggers. You really need to think about that as a strategy. The other one I'd throw in from the embedding side is you also need to think through what would happen if you ever wanted to change the model, or perhaps if you have a new version of a model. And you need to think, well, do I then just regenerate all the embeddings? The dimensionality could change if the model changed. So you need to think through the whole process of how would I maintain this going forward. But the next main section I want to talk about here is intelligent search. And we've had a number of options here in SQL for a lot of years. Search is one of my favorite things inside the product. And SQL Server 2008 was the first one where I thought we started to have a pretty good story. We had full text search became, I consider, usable back in 2008. Prior to that, it was, let's just say, a little challenging and a little slow. But what we have now from that point on, if you think about what users want, the problem is if you say, well, what do they want? And the answer is they don't know. And they also want to use their own words and they want it fast, right? So this has always been a challenge because as IT people, what we tend to give them instead is we give them highly constrained searches in our own terminology, and we don't often give it to them very fast either. So this is completely different to what an end user wants. And so if you look at the strategy decisions we have now, with full text search, when you go to match with that, it's looking for exact words and stems, but it can also find synonyms. And it mentions there only with thesaurus. So there was an option in SQL Server when you do full text indexing to add a thesaurus in there. So you have synonyms can be part of that, but also a thesaurus. And important to understand that the thesaurus was an external file. And for that reason, when they migrated to Azure SQL Database, the thesaurus isn't there. And so there's a difference between SQL Server and Azure SQL Database for that. But importantly, what that meant is that if I had a word like customer, I could have other words like client or punter, maybe from the UK or something. But the idea is you could say, look, when I search, don't just search for the word I use, search for all of these different options instead. So that doesn't handle typos, but it does handle different versions of that. The other thing that it does do is it understands sort of stemming of words. And the idea here is that if you're a human, the word drive and drove and driving, they're all related to the same concept. But of course, normally to a search engine, they're completely different words. And so it does understand that as well in full text search. So it takes the words, it stems them down, and then it stores that in an index, which you can use to look things up quickly. Where vector search is a completely different story. What that's saying is, let me take the text, derive the semantic meaning of it. So where does it end up in vector space? And then things that are related or very similar end up closer together. And so the beauty of this is you don't have to go through and configure synonyms where you say, you know, when I say customer, I could be meaning client. You don't need to do that because it's using a large language model effectively in the background that already understands all these things. And so you get that sort of thing for free inside that. Now, the beautiful thing with that is even if you have typos and things, it understands often what you're actually trying to get at. It's fast, but it's not very fast compared to what we had with full text search. And if you look at the complexity of setting it up, full text search is nowadays very easy. Vector search, there's a bit more work, but also there's more work with potentially with the maintenance of this as well. And if they compare the two, we're saying full text search is best for exact keyword searches, where vector search is better for natural language queries. And of course, the beautiful scenario is to use both. And so we can have hybrid search where we look at both keywords and meaning, where we use both of them together. Even if you're using vector search, it's very common that you're not going to use that style of search necessarily right across entire tables and so on. It's a very high computational overhead in many cases to do this. So what you often need to do is don't forget, you're still going to want to have your standard relational predicates. I mean, your where clauses with, just find me the rows for Queensland or find me the rows for Victoria and so on, and for maybe a particular salesperson. That sort of thing is still super important to restrict the number of rows that are important in the results that are going to be returned. Now, to implement full text search, you need to know how this works. So you create a thing called a full text catalog. It's a strange concept nowadays because originally a catalog was actually a folder out in the operating system. And so it was like a physical thing. Nowadays, it's just a logical container for indexes. That's all it is. You then create a full text index on the target columns. Part of creating that is you have to have a unique key on some column. So it needs to be able to identify particular rows. That often will be the primary key of the table, but it can just be a unique key. And the other thing you're doing is you're choosing a language as part of that. Now it's got the functions. So contains says basically look for these exact words. My favorite one is free text. Free text says, find me something that's about this. And so that matches, as I said, using stemming, thesaurus, if it's available, and inflectional forms of the word. This is the drive, drove, driving, and so on. Now, as well as those two functions, there are table valued functions for both of them. So contains table ends up being something you could join to, for example. And so that'll go through and look at the entries in the table and give you back the rows you can join to. Where contains is something you'd normally use in a where clause, or perhaps in a select clause, but usually in a where clause, and same with free text. And so similarly, there's also a free text table, goes and says, find me the things that are about this, return them in a table, and then I can join to that. Whereas when we have vector data types and the strategies for those, we need to create vector columns to store the dimensions. Now, the number of, or the size of the dimensions for these things, the smallest models I've played around with tend to have 384 dimensions, but it's common for that to go up to often thousands, 3072 even is fairly common. But 1536 is often a pretty good standard size. There are models that go higher than that, but you've really got to ask yourself, is that where I want to be? Because you also need to think about what this means in terms of storage. Imagine if you've got rows of data about, I don't know, a product, for example, and you might imagine how many rows end up in each page of the database. And you think, well, this is a concept we're quite used to. But then all of a sudden think, well, hang on, if I added 1,500 odd 64-bit float numbers onto the end of each of those rows, all of a sudden, how many rows are going to fit per page? We're fast moving into a scenario where in many cases, you're talking about one row per page and potentially also using overflow pages just to store one row of data. So this is going to fundamentally change how we think about designing the databases. In fact, I do wonder if somewhere along the way they're going to have to rethink the what are typical page sizes, simply because it was all designed on the basis when we had lots of rows in a page. But you have to then think, well, do I put the vectors in the same table, or do I put them, denormalize it and put it in another table associated with it? Need to decide that. The other thing is that when you do comparisons and we say, how similar are these values? There are 3 distance metrics that they've provided. So cosine is direction similarity, says, is this in the same direction as the other vector that you had? Where Euclidean is a little different, where this is then looking at the points and then saying exactly how far apart are they, as opposed to the cosine one, where effectively what they do is they move the vector down to a unit size vector to just a size of 1, and then they compare the directions. Where with Euclidean, what we're talking about is, doesn't matter how big or small the vector is, we're looking at the endpoints to compare them. And a dot product is the combination of the direction and the magnitude. Now, the 2 words that you'll see used extensively in amongst this, in fact, 3 of them really. ENN is what's considered exact nearest neighbor. And that one is effectively saying, look, go through all of the rows and work out exactly which ones are close or not. And the beauty of that one is that it's very accurate by comparison. That's often also called KNN, so ENN or KNN. When you have KNN, the K is just the number of neighbors to find. So it's find me K nearest neighbors. That's what the K is. And then we have approximate nearest neighbor, and this is what happens when we have indexes in place. And there are different standard indexes that are used for this. So HNSW, and there's others in the industry like IV flat and so on. These are common algorithms that are used as part of a vector index. But the one that's used in SQL Server is HNSW, which is the hierarchical navigable small world algorithm. But anyway, it's the one that ends up being used. Now, when you have a vector index in place, you can then do vector search. So whether you have an index or not, you can calculate a vector distance between things. But if you want to do a vector search, then you have to have an index there. Now, one thing to note, you'll note the syntax that's shown there on the right-hand side for vector search. It's important to understand that this is a moving target. When SQL Server 2025 was released, this was a preview feature, the vector indexes, and the queries that we used for the vector search were of that format that's shown on the right-hand side there. And of course, keep in mind, that's about at the time the exam was created as well. But if you're working with Azure SQL database and you create a vector index nowadays, it actually creates a second version of the vector index, and it requires a slightly different syntax when you do a vector search. And so it has a concept of with approximate, and so you end up saying select top 10 with approximate from vector search, and you don't have the top n inside the query. So just keep in mind you'll see documentation on 2 different versions of how vector search works. Now, the reason they changed that is that in SQL Server 2025, the original version of this, when you apply a vector index to a table, the table becomes read-only. In Azure SQL Database, when you apply a vector index to a table now, you get version 2 of the index, but the table still stays read-write. And that's a really big difference. We're all hoping that that'll end up as some sort of update or something to the on-premises SQL Server product somewhere in the future. Now, the final sort of basic concept here is what they call reciprocal rank fusion. And so when we have full text search, and as I said, with contains table and free text table, and we have vector search, where we're using, well, you could just do vector distance if you wanted to plow through all the rows, or you could do vector search. The two of them combined produce what's called reciprocal rank fusion. The main idea here is that it's able to take the results from multiple queries or multiple search styles and combine them together without requiring each one of those different searches to have the same sort of scoring mechanism. Now, when you have search in place, you need to be able to evaluate how good is the search. And so the words that we use in relation to this, so the first is recall, and that says what percentage of the relevant things were found. Now, if you have KNN, or as I said, ENN, you end up with potentially 100% recall. And that's because you're going through and looking at every single row. Where ANN, where we have a vector index, this trades off a little loss in that recall for speed. If we have latency, ANN with an index, which they call disk ANN index, is orders of magnitude faster than running through all the rows in the table. It's no different to any other sort of index in SQL Server. You can imagine that if you have a query that the index satisfies, it's good and quick compared to reading all the rows in the table. Now, precision says, okay, now it's not just a case of how many did I find, but how many of them were actually relevant? And so did it find me things that weren't the ones I want? And hybrid search usually gives you a better outcome with that. And finally, of course, the index overhead. Any vector index is going to consume a lot of resources. And as I said, just keep in mind, we're talking about 64-bit float values of the default that ends up being stored in the vector columns that we have. They're going to be large. And so any sort of vector index built on that is going to be pretty big as well. Now, there is a preview feature as well that allows you to use float 16 values and instead, and that makes things obviously drastically smaller, but that's still in preview. And of course, it has a loss of potential value in terms of the performance of the index. But that one, just keep an eye on it, because in many scenarios, that might drastically cut down the size of what you're looking at without tragically affecting the results, shall we say. But it might keep the size manageable. And so, look, the key takeaways in this area, we're saying full text search does a great job at exact keywords, and vector search is the missing link for semantic meaning. And of course, hybrid is both. So vector distance just says how far apart are these things, or how close are they when we look at functions that are related to vector similarity. And vector search instead returns you back a table that you can join to. We said KNN is basically K nearest neighbors done using ENN, or exact nearest neighbor. And so that's 100% recall, but it's brute force through the data. Where ANN gets you up into the 90-odd% recalls, but this is approximate nearest neighbor, and that uses an index for speed. I said with approximate is the T-SQL keyword that's used to go between them. RRF, or reciprocal rank fusion, I mentioned, takes the outcome of different searches and combines them without needing to normalize the scores first. So it doesn't matter what scoring pattern each of them uses. And if you look at the distance metrics, we mentioned cosine, Euclidean, and dot. Cosine is the most common one that's used for text embeddings. So you need to know all of them, though. But nonetheless, so Anu, tell us about RAG.
Great. Thanks, Greg, for the detailed explanation about the different types of searches and how you use it. But because you now learned about like what semantic search is and why it is important, and now it is important to focus on RAG and how do we use that with SQL and what is RAG and when do we use it? That is the first thing you need to understand. RAG is nothing but retrieval augmented generation. And why do I really need RAG? So if you ask a question to a large language model, right? So there are a lot of large language models are available. You ask a question and it is going to give you a response. Then the question comes in, why do I really need to go for something different like a RAG? So let me give you a simple example, right? So you are asking a question to say like, okay, give me all the public holidays in New Zealand because I'm from New Zealand. So it is going to give you the large language model is not going to worry about it because that information is available publicly. It is going to give that information. But if I just go and ask the question to say like, okay, can you tell me whether my company is going to reimburse me for if I purchase glasses? And what do you think the large language model is going to do in that scenario? The large language model doesn't have any clue about your company's policies or anything. So it is either going to say, sorry, I don't know, or sometimes it can give you a vague answer, which is what we call it as hallucination. So how do you answer these type of questions? And this is what we are getting to see more and more with a lot of enterprises, right? So they are saying like they have a large volume of information. And when people are looking for information, they want to serve it, especially for their customers. They want to serve it from their data sources. And that's where RAG pattern comes into the picture. So with retrieval augmented generation, basically what it means is you can augment your data source. And now you can understand why we have RAG pattern inside SQL Server, right? So most of our customers, they have their data in SQL. And what they really require is like, okay, when people are asking a question, rather than going and looking for the publicly available information, how can we give the information or more reliable, accurate information that what we have got to them as search results? And that's what RAG pattern is all about. So classic example is your customer service chatbot, anything that you do, that's exactly how you will be starting to look at from a RAG. One thing important to notice, what to RAG and what not to RAG. So make sure that you look through that prepare for that for the exam, because there may be some scenarios that may be given to say like, okay, do you use RAG for this or not? But how does a typical RAG pipeline works in T-SQL? So basically what we are going to look at is like whenever we are going to ask a question or what we call it as a prompt, it is going to go and search for that information in your database. So see, it's not going to hit the large language model straight away. It is going to go and search our database. In our case, it is SQL, going to find all the information or search results that are semantically related to the question that was being asked. It is then going to format that into a JSON structure. So this is the output. And now your prompt is going to be rewritten. Suppose if I ask the question like whether my company is going to reimburse for glasses, like that information, the search results that are coming, which will be in JSON, converted into JSON format, right? So now my prompt is going to be updated. So it will have the question, but also the JSON results that was extracted from my database will also be appended to the prompt. And then it is going to be sent to the LLM model. So this is when we will call the LLM endpoint with this modified prompt. And what the LLM is going to do is, rather than it's going and looking for the answers, it is going to take this JSON that came along with the prompt, and it is going to convert the JSON into natural language response and send it back to the end user. That's how a typical RAG pipeline pretty much works in T-SQL. So if you take this as an example, so here you can see the user asks a question or what we call it as a prompt. Keep in mind, because we are actually vectorizing the data in SQL, we have to do the same thing when people are asking a question, because you are not going to compare a text against a vector, right? So you have to compare the vector against the vector. And this is where in the previous module, like Greg covered of how the semantic search works and what are the different modes that you have got, like the cosine mode, or how you can find out how two pieces of information are related to each other or not. So how do you do that? So you take the prompt, whatever that is given in text, and that prompt is going to be converted into vectors first. And that is what it's really important. Then it is going to be, once it is converted into vector, it is going to use the vector underscore distance function. So that is what is going to be used to figure out what are all the results that are going to be nearest to this question that has been asked. And as you can see here, you have got the cosine mode is also included in there, because that is the most common one that we use in terms of calculating the distance between the vectors. So then moving on into step 2 and 3. So here, once we have figured out like, okay, what are all the related information for the prompt, now we have to convert into JSON string. So we have a lot of built-in JSON functions that are available currently with SQL Server 2025. So you will be able to convert the search results into JSON array, and then you can go and do the next thing, which is updating our prompt, because now the prompt needs to be not just only the question, the prompt needs to be including our question along with what we call it as the JSON response or grounded response. So this is the grounding data, which is actually coming from our own SQL database. So that's important thing. So if you look at any typical prompt structure, right, you normally have a system message, and this is where you give any common instructions, generic instructions or guardrails saying, I want only the answer provided for the context of the question. If you don't know the answer, just say no for it. Because if you don't say that, your model is going to hallucinate. So it's always good to get some like a guardrail set as part of the system message. Then the context injection, which is basically the grounding data, which is what we have got, that we have to send it to the LLM model. And then the user message, this is the original question that the user has asked. So what we are going to do is that we will be combining all these three as a prompt structure, and we are going to pass it on to the LLM. So how do you call the LLM from SQL? We'll be invoking the SP invoke external REST endpoint, and this is the procedure that we are going to call. And we are going to say this is the model, and here is the payload, like which is basically the modified prompt. And then you are going to wait for a response from it. And the response, what you are going to get is basically a JSON response, but it will have the natural language response that you need to provide it to your end user. Of course, you will be using the built-in JSON functions that are available in there. Some important things when you are working with these type of T-SQL functions, as Greg was mentioning, right? Make sure that we are calling external endpoints and stuff. So it is really important for us to handle the errors. So enclose them in a try-catch block and try to any external API calls you are using, try to wrap them up so that you can really figure out where the problem is. Is it the problem with the external API call is taking longer time, or is it timing out? Because with LLM models, you know that scenario where whether you have got enough tokens available in that region, whether the service is available in that region. So there are a lot of variations where things can go wrong. So it is always important that you manage the error handling in there. Good. So the key takeaways from RAG, as I said, RAG is all about getting relevant data, or more, I would say, like accurate data from what you have got to give it to your customers. And it is basically like going to create what we call it as a grounded response with your own data. So don't forget that part, like mainly like when you are asking a question, it is going to go and search your own data store before it sends it to the LLM model. And when you are when to use RAG is if your data changes more often, RAG is more better than fine tuning. So the difference between RAG and fine tuning is RAG is actually it is searching your real data in there. Like in my scenario, it is SQL database. It is going to go and search that table and get that information for me, right? Whereas with fine tuning, there is going to be static or stale data, because fine tuning is like a process, like a machine learning process where I have to go and feed the data, train the data, test the data, and then it is going to be, so every time when the new data comes in, you have to go through this iterative process. So when you compare with fine tuning, RAG is much more good, especially if your data changes more often. Don't forget the SP invoke external REST endpoint, because that is the bridge between T-SQL and your APIs. So when you want to call the LLMs, which are hosted externally, this is the store procedure that you will be using. These are some of the JSON functions that is going to come handy for you if you are using RAG, like the JSON object, JSON array, all the things that are listed in here. It is important that you prepare for all these functions for your exam. And always instruct the LLM, because what you want is the answers is based on what you have sent and nothing in terms of hallucinations, because otherwise you're not going to give the accurate answer what you're looking for. And make sure your answer is going to be accurate based on the data that you have got. Because everyone thinks like, okay, I'm implementing RAG, but if your table is not going to have accurate or relevant data, your response is not going to be relevant either. So retrieval quality is what is going to drive your RAG quality. So out of all the three things that we saw today, like we talked about models and embeddings, these are the key areas that you need to be focusing on. Learn about create external model, different chunking strategies, how do you use the AI generate embeddings function, the vector data type, understand about it, how data gets stored, and what is that data type in SQL Server, and what are the different ways of maintaining my embeddings inside SQL Server. The second part you learned about is the intelligent search. We talked about full text, what it is and what are the functions related to that, vector search and the vector distance function, and the differences between ANN and KNN, and also like what is the difference between full text, semantic, and hybrid. So hybrid is a combination of your full text and semantic search, which is in a lot of cases people tend to use it. And also, like Greg talked about the reciprocal rank fusion, which is about re-ranking everything, especially in hybrid search, it is going to be really handy. Then you have got RAG with SQL. So we talked about the entire RAG pipeline. So how you actually get the information, how the search results is extracted, how the prompt is getting rewritten, and then what the modified prompt is what you're going to send to the LLM model, and how the LLM model is finally going to give you the output in a natural language format. We also talked about what goes in system messages and what goes in user messages, and also like how do you extract the response that you get from the LLM model. The interesting part is all these things that you can now do with SQL. So previously we have to build applications to interact with APIs, data is sitting in SQL Server, but now I don't need to even build any application. I can straight away do my interact with my LLM directly from SQL Server, that too using T-SQL statements.
So look, that brings us pretty much to time. I just want to mention that preparing for the DP-800 exam, as I said, it is a substantial exam. I did it in the beta phase, so I was a little unsure of what to expect at the time, but it ended up being interesting. But as I said, it's quite broad. The main thing I'd suggest you do is obviously go through all the Learn modules that are there now and make sure you've done all those. But importantly, grab the study guide. And this is the same for any Microsoft exam. What you need to do is look at every single bullet point that's on the study guide and seriously ask yourself, not just maybe, but ask yourself, do I really understand the topic that's discussed in the bullet point? Because keep in mind, the exam writers are looking at the same study guide and they're looking at the different points there and then determining what to ask questions on. So you need to make sure you're comfortable with all of that. The other thing is to make sure you're also very comfortable with working with Learn content in general. Keep in mind that most Microsoft exams that are role-based nowadays give you access to Learn content while you're in the exam. Don't overdo that though. I've seen people just waste far too much time searching for things. Look, go through, answer your best answer for most things. If you have a question, flag it to come back to it, then go back and if you're going to spend time looking through Learn content. But importantly, make sure you know how to search effectively inside that Learn content as well. Do the practice exam when that's live, and obviously schedule your exam. There is a session coming up on what to expect on exam day. But we mentioned earlier, you can get certified for free and strongly encourage you to. In fact, if anything, the best way to find out what's sort of things are going to be in the exam is to take it, right? So, but I mean, don't waste it. Just wait until you feel that you are pretty comfortable with what's going to be in there. And look, I want to finish, as I said, thank you for being here with Anu and I. And I know there's other places you could have been rather than watching this. I really want to thank you for being here. And of course, a huge shout out to our moderators who've helped us in the session. And thank you, Molly. We're done.
Great. Thanks, Greg. See you, everyone. All the best.
Thank you all for joining, and thanks again to our speakers. This session is part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.